Hello, welcome everyone to this webinar. The Develop of the Future starts here. I'm honored to have here today with me Vladimir. Vladimir is a technology evangelist with more than 23 years of experience leading global professional services, consulting, and delivery organization. He's a visionary leader. Vladimir approaches transformation through technology sourcing, cloud computing, global shared service, enterprise system, and optimize of IT as a service. So Vladimir's experience includes working in more than 20 countries with projects spanning all over the world with budget crossing $2 billion. So he's definitely an expert, and we are really glad that he's here with us today.
So thank you, Tristano, for a nice introduction. Hi, everybody. My name is Vladimir Baranek. I'm author of PCD Professional Cloud Developer course, and I'm also CEO of Synthetic Spheres. Let's start with this slide, which is slide number 14 in our presentation. What we are trying to show here, it's a very nice section and a couple of slides we have about this of statistics and analysis about current situation with the cloud. So let's start. The growth of cloud continues, and the statistics shows that trends are highlighting the same issues. In the next few slides, we will look at what is happening in industry. The first big number where we got is 204 billions from Gartner. What does it mean is that this is the cloud market today, and it's 16.5% increase from the last year, which was 175 billions. And these are all these numbers are coming from Gartner, so hopefully everybody believe them. Next, cloud application services or software as a services are also expected to show an upswing with more than 20% year-over-year growth, reaching 40 billions. Which is quite a big number, considering that except a couple of standard players like Salesforce, NetSuite, Workday, this is the space where we do have most of startups, so that number is growing very quickly. Cloud management and security services have more than 24% growth, and platform as a services 21% growth. And platform services is actually what we are looking for. This is application development. It's pure cloud native application development, and it's quite strong. Next, in 2015 Evans study found nearly 3/4 of organizations are currently using some form of cloud-based development tool today for more than 25% of their workloads. That means even if we are talking about infrastructure as a service, all the administrators, developers, everybody who is administrating or operating any workload is switching from standard tools to cloud-based tools, which is pretty significant. That means that they are able to seamlessly monitor and manage all workloads across the clouds. Based on the computer world, developers have had the most impact on bringing cloud platforms into their businesses, driven by shadow IT to solve needs and innovate quickly. Amazingly, this means that developers are driving cloud adoption way faster by moving new applications and refactoring of existing applications into the platform as a service platforms. And as I already mentioned, majority of startups are focused on software as a service development as the ultimate business model for subscription-based offerings. Almost all of the software as a service development, native cloud-based development, is running on infrastructure as a service or platform as a service stacks. So we do have a bit more statistics here. In this case, this is from Salesforce 2016 State of IT report featured on Forbes.com, in which they surveyed global CIOs and IT leaders from US, Canada, Brazil, Australia, Japan, France, UK, and Germany. What did they find? Well, 79% of IT teams are currently developing cloud apps for customers, partners, and employees. 79%, that's a huge number. If you will compare it like 3 to 5 years ago, when you will find out that people are just trying to be early adopters, or they're moving a couple of workloads into the Amazon or somewhere. So actually, almost 80% of all developers in big companies are developing for cloud already today. Now, 68% of CIOs predicts they will spend more on mobile applications in the next 2 years. So obviously, they are focusing on mobility first concept, and that's definitely cloud-based development. What they found next is that developing talent with IT skills development and training are second at 46%. So skill development of cloud native developers is 46% of their priorities, which is, as you see, first important thing for everybody. For if you are trying to do any cloud migration, to move anything into the cloud, development of IT skills in order to run it and develop anything under the cloud, it's basically the most important thing. Once it's there, you have to do that. Now, 33% of IT teams struggle to keep up their skills with emerging technologies, and 32% struggle with lack of skilled developers. And that's exactly what we are talking today about, where we are finding out that we don't have enough skilled developers with native cloud skills. There are plenty of developers which are good, but they don't possess cloud skills. Next slide. All right, at the same report from Salesforce, we find out a bit more graphs here for mobile applications, cloud migration, etc., etc. And as you see, all of them are big numbers, and it could be affected by the Salesforce this report, because that's software as a service company, and everything what they do is native cloud with their own Apex language running on force.com. But those are anyway, those are really significant numbers, and it's just growing. Okay, let's go to the next slide. This slide basically shows something very similar. It says what is the lack of skilled developer here. It's 32%. That's 32%. It doesn't necessarily mean that they don't have developers. It means they do have. There is a lack of skilled developers. That means cloud native developers. Just below that, you get lack of resources for IT skills development, and this is related to basically infrastructure as a service, operational skill set, etc., etc. Let's go to the next slide. All right. In all of these slides, we basically are saying a lot of things related to cloud demand and challenges. And in this particular slide, the hottest skills of 2015 on LinkedIn, this is the global statistics, says that number 1, number 6, number 9 is related to cloud and cloud development. Those are the hottest skills on the market today, and we can see very similar statistics on the next slide from Computer World. So please go to the next slide, where these statistics are not just IT statistics. As you see, it's mixed with networking, with business strategy, etc. But number 1 is IT architecture. Number 2 is development. Number 3, 4, 5, 6, 7 is cloud/software as a service, which is also development, just different one. And then in three numbers down is web development. So if you will calculate everything together, we'll find pretty interesting number, which is really saying that cloud market is more than ready for cloud developers. Let's go to the next slide. And go to the next slide. Okay. And over here we see very similar thing. What is important is if you will combine cloud SAS with programming and application development, it's the number one. It's basically the development is number one for skills which are hard to hire. And for me personally, it's not surprising. It might be surprising for a lot of people, which were always telling us that, security is the biggest problem here. Everybody acknowledges that. That's why a lot of clouds are, focused on compliance requirements. You got HIPAA, PCI, etc. But skill set is something which is becoming more and more important once everybody's moving to the cloud. And we will talk about security a bit later on, but definitely the skill set is something you can't just buy by moving to the cloud. You actually need those people. Let's go to the next slide. Okay. And over here, what we see, number one at the right scale, State of Cloud report this year, is lack of resource expertise. And again, it's first in front of the security. Not a surprise for me. Again, a lot of surprises for other people. The main problem I see here is usually people are moving to the cloud or are doing this kind of decision based on a lot of business factors, and a lot of organizations are really not thinking about what about our developers. If they will outsource everything, it's still the same challenge, and a lot of internal resources such as developers, such as operating managers, are really not ready instantly for this plethora of technologies which are waiting for them at the cloud. It really requires a different mindset. Okay, let's go to the next slide. All right. So what we have here is about time and money savings. What does it mean? Well, the Salesforce study found that 63% of companies operating in the cloud can develop an application in less than 3 months. 3 months. So obviously, this is a pretty general number, but it's interesting that if you will compare this number with anything that was developed before the cloud, it's pretty low. That means cloud is actually increasing the speed of development. And the statistic says that 72% of high-performance companies can generate an application in 3 months or less. In contrast, only 46% of underperformers can do the same. This ties into the level of investment that high-performing companies make in training, which is nearly twice as much as lower-performing companies. So high-performing IT teams are 1.8 times more likely to spend on customer-facing applications. They are also 1.4 times more likely to plan on increasing spending in mobile applications. So overall, 76% of high-performing IT teams predict they are increasing spending on customer-facing applications and mobile applications mostly. Next slide. In addition to that, also Evans Data Cloud Development Survey revealed that cloud application development saves developer 1 hour of every 8 hours. So, which means basically that cloud developers are 8 times more efficient than standard developers. Development on cloud platform reduces overall development time by an average of 11.6%. That's just different statistics about the same numbers. Now, utilizing developers in cloud platforms enables streamlining the development process, including the ability to quickly get the development assets online. Also, cloud developers have the ability to collaborate with other developers, architects, and designers on the development of the application. In addition to this, majority of organizations are planning to spend most dollars on high performers, which in translation means increased spending on true cloud developers delivering customer-facing and mobile application over the next 2 years. And this comes with a strong prediction to continuous growth beyond this period. In this section, we will start talking about our PCD Professional Cloud course, what is inside, what we are trying to cover there. And before we will get there, I want to spend some short time period about general question where people are asking what developers need to keep up. What is the characteristic for next-gen developer for cloud? So we believe there are 4 points in order to be a good next-gen developer, and they are architecture mindset, cloud-related skills, DevOps master, and cloud tool adoption. Let's start with the first one, architecture mindset. So historically, a responsibility of deploying and operating this code is often handed to another group, with a software developer having little input or knowledge of the production environment. However, developers today must take a bit more holistic operational mindset approach to their work. They must really understand full-stack engineering, including deployment automation, and possess an understanding of the infrastructure supporting the application and the non-functional characteristics of the application too. There are multiple areas related to this architecture mindset. To name just a few: deployment topology, operational environment, points of failure, data encryption, access and authorization, scalability, key monitoring metrics, and more. Well, unfortunately, most developers don't approach development project with this mindset today. And as we move to the new era of cloud development, like deploying, configuring, and operating a cloud application, is much more important and more difficult than developing the function. So what we are trying to say here in this section, the architecture mindset, is that developing itself is important, but the architecture is probably even more important in order to develop something which is automated, robust, and which is really resilient, which could be developed natively inside the cloud. And it comes and starts with architecture mindset. So next characteristic is cloud-related skills. Well, cloud developers need to have a basic understanding of cloud resources and how they relate to one another. Building cloud-native application is very different from building isolated package of application that runs behind a firewall. To do this effectively, developer must know multiple advanced techniques to scale applications, support monitoring, and accessing spanning multiple availability zones, build, automate failover, implement replication, integrate security protocols, etc. So cloud services are constantly evolving. They are more interoperable and granular than ever. A good example is virtualized containers such as Docker, which eliminated the need for virtual machines, therefore enabled transition from administrators to developers running their own environments. cloud developers should deeply understand how to leverage cloud for developing resilient, high availability, and cloud native applications. Well, at minimum, all cloud developers need to understand basic cloud capabilities if they plan to build cloud native applications. So this cloud related skills, this whole section is basically focused on patterns, cloud patterns, and various techniques how to implement them. That's very important. And actually, this is part of our course where we are, I think, even first of the sections, first module is related to this. All right, next characteristic is DevOps master is adoption of DevOps practices. Well, today in the era of access, anything is a service. It's necessary to operate your application within a cloud environment with repeatable and reliable process in order to enable automated deployment and configuration of your cloud resources and components deployed to the cloud. The only way to effectively automate the delivery of changes to your applications running in the cloud, and it's whether public, private, or hybrid, doesn't matter, is by following strict DevOps processes with assumption there is no disruption to production environment, which is the most important piece, because everybody is expecting, all right, I am paying for this software as a service on subscription based, it just must run. So everybody's quite surprised when suddenly Amazon is down or something is not working on. It's also important to apply lean startup thinking when developing cloud applications. Fundamentally, DevOps practices are essential to continuous delivery of change. What does it mean? This whole section, this whole characteristics for DevOps master is related to real automation of deployment and orchestration and configuration on the run, which was not always possible on isolated environments or somewhere at the local on-premise data center. All right, the last one is focused on cloud tools adoption, the last characteristics. And basically over here, what we are trying to say, all developers are moving for classic tools, for traditional tools, to DevOps tools. And DevOps tools are on high rise right now. Based on the RightScale State of Cloud report from this year, 2016, there is a huge increase of DevOps tools used by developers, not administrators, but developers. To name just a few is Chef, Puppet, Ansible, Salt, Mesosphere, etc. Then from container perspective, you've got Docker, Kubernetes, Docker Tutor, etc. The increase is in some of those more than 30% of usage from previous year. And the prediction is that for next year, the plan is, especially for container-based toolset, more than last year, more than 30-35%, which is amazing. That means from last year and this year, the increase of usage for DevOps tools is more than 60% than it was 2 years before, which is quite a bit of crazy, because if you think about that, many of those tools are running online only. I think a lot of people are amazed by that. And so this is the first slide, and we already talked a bit about the patterns. This is the first slide of our PCD Professional Cloud Development modules. So actually, this is the first module over there. What I would love to highlight here that the whole course, everything what is inside is vendor neutral. We are trying to be objective, and it's trying to point in the view of development in the cloud environment, and it's pretty up to date today. I think we are trying, and we will try to update this course every year to make it up to date. So this first module, Cloud Architecture Pattern, let us take a look at a couple of things. First is multi-factor, multi-form and platform factors, which means we are talking about target deployment models and platforms. Next, we will talk about cloud caching, where we will distinguish between distributed and federated cache. From patterns perspective, we will also focus on RESTful versus restless services and session state management. We will, examine quite important pattern, designing for failure, which is basically designing to expect failure. That means we have to expect everything can fail. It's a bit different approach than standard applications. The next is a bulk API for bulk data uploads with lock-in mechanism. This one is quite important for big data and for migration of data from on-premise to off-premise. Next one is stateful versus stateless, quite important for a lot of people. And then we do have foundational knowledge about cloud parsers in this module is the last section. All right, let's go to the next one. Next slide. Module 2 is dedicated to service modularity, encapsulation, and orchestration. And basically, this is kind of connected to what we were talking before about DevOps. And we are even, going a bit further here about with comparison between DevOps versus NoOps. A lot of people would ask, what is NoOps? In my point of view, NoOps means that you really don't need anybody from operational perspective to run your production, which for a lot of people seems like that's an nirvana or something nobody can achieve, but trust me, it's done for a lot of companies. All right, so what we will talk about over here is migration and encapsulation of existing legacy apps to a cloud platform. Next section over here is exposing business logic as a web service, which from my point of view is a real enabler of business process as a service. Historically, we were trying to do that with SOA many years ago, software-oriented architecture. Unfortunately, it was very bulky, and today, there's still a lot of organizations, especially big organizations, which are using SOA, and I think there is still a place for SOA in this world. But this is a bit different business logic as a web service, and everybody who attends this course will hopefully understand why. Next, we will talk here about cloud messaging. That means message queues, how to do that, and what are the important patterns of messaging. We will look at the integration of database as a service. Again, very important part. We'll talk probably, about SQL versus no SQL databases and why we still think that SQL databases are important as well. Even though everybody today, is deploying and building a lot of applications on SQL databases, such as MongoDB or memory databases, Redis, etc. Then we will talk about transactional coding in the cloud, which is again connected to databases. All right, let's go to the next slide. Monetization techniques. For a lot of people, this is really interesting area, how to make money on this. So we will talk here about license models. We will compare each of those. We will talk about developing for cost, which is basically a cloud paradigm, and you will learn more again at the course. We will talk about hidden cost of cloud development, because it really looks like it's for free. You will take the cloud tool and you will spin up a couple of instances for free, or you will deploy your node applications on Heroku, and you will use free dynos. Well, that's true, but production is never for free, and even usage of a couple of tools or advanced subscription models are not for free. So that's why we will talk about hidden cost of cloud development, and especially if you are using different architecture blocks and different providers. Let's imagine, you are going to deploy something at Amazon Web Services, and there are multiple blocks you will construct together for your target architecture, and I will guarantee it's not for free. We will talk about software license models. Again, we will do a comparison of those. Then we will talk about differences between in-source, outsource, and crowdsource, crowd development, open source, etc. And at the end of this section, we will talk about monetizing applications through application markets. And we will further extend this discussion about application markets and at a dedicated module later in this course. Well, let's go to the next slide. This is a pretty important topic. I think everybody understands that. We will examine OAuth, SAML, and single sign-on supported in cloud environments. We will discover integration with identity as a service, which is basically a very important piece for a lot of cloud-only applications. They are seeking to integrate existing identity as a service piece. That means that they don't have to build this sort of or this component by themselves. Again, we will talk about advantages and disadvantages here. We will talk about concept security at every layer. First we had security parameterization, then we went back to deparameterization, and now at cloud we are talking about security at every layer. Although there are a lot of different points of view where we are saying that it's not just on every layer but on every component. But I think this is for a way longer discussion than we have today here. Next, we will talk about custom security roles, which are deployment descriptors. We will dig quite deep in this subject. Another one is encryption and anonymization techniques. So that means this is encryption and anonymization of data. And at the end of the module, we will talk about developing for compliance. That means we will quickly describe what it is and what are the compliance requirements such as FISMA, FIPS 140, PCI, or DSS. Let's go to the next module. Well, this is my favorite. I really love metadata and semantic. So we will talk here about semantic fundamentals. We will examine semantic stack. We will talk about RDF and OWL, OWL, and we will take a look at open metadata APIs, and we will also talk about linked data, which is pretty much a very interesting fact, especially if you are trying to develop something semantically based. A lot of people really don't paying attention to this, thinking, that's just, Wikipedia or a couple of triplets, and we don't care about that. In the truth, reality is a bit different. A lot of developments are starting to be based on semantically based metadata, semantically based databases. And if you will take a look outside, then you will see that this section is very humble in comparison to what is happening today, and I'm guessing that we will update and extend this section even more. Let's go to the next slide. Testing and deployment in the cloud, quite important for a lot of organizations. What we will talk here is cloud testing deployment and goals, why we are doing that, and what are the deployment models. We will examine generic stages of cloud and non-cloud testing and development life cycles. We will take a look at the utilization of crowdsourcing for massive cross-platform testing, which is basically crowd testing. If you will take a look outside and try to take a look at the landscape for crowd testing, then you will find out there are a lot of companies which are focused just on that, especially for mobile applications. And you know, the business model behind it is usually based on pay per bug. That means you don't pay per hour for all the testers, but you can have like 1 million testers for free, and you will pay for the bugs you have to fix, which they found out obviously for you. And those guys doesn't necessarily need to be, you know, just a regular folk somewhere from, you know, development countries. They're all over the world, and many of them are really qualified to do this kind of testing, which is important to know. Next section over here is cloud testing automation. That means how to develop a script for testing. Another section talks about cloud components, packages, and solution testings. So basically, we will take a look at the testing from architecture perspective. Then we will quickly examine cloud testing frameworks, and we will compare public sandbox versus private sandbox features, which is also important because everybody thinks that, you know, sandbox is just a sandbox. There is no difference. Well, there is, and especially we'll find out at the testing stage. Next slide. Scalable coding. Very important part of this course. Basically, from a cloud developer's perspective, we're expecting all code is scalable. Otherwise, we can't do, you know, application scaling. We can't do horizontal scaling, vertical scaling. We can do it by hardware, but that's not very efficient. So we need to build our application with scalability in mind. And what we will learn here is about polyglottism or coding languages in the cloud. That means that we will take a look at cloud-native languages, non-cloud languages, we'll compare them, and we'll take a look at overall history of the languages, which is very interesting. And a lot of people are surprised how their, you know, favorite language developed from something they never thought about. Next section is designing to handle massive success, where we'll talk about agility of developed solution. And the last section, very important, is performance engineering for scalability, reliability, and recovery. That piece is covered with tips how to develop something which is scalable, which is reliable, and which could recover. And there are a couple of very good slides about how to do that. Next section. Next screen, next slide, thank you. Deployment automation and elastic sizing on environments. This is going more to the infrastructure as a service side, but it's still engineered, it's still developed, and over here we are in majority of the cases using those cloud native tools. What we will talk here is service and application deployment into public, private, and community clouds. So even if you are developing something very small, you want to deploy it into the cloud, and how to do that. And we will, part of this section, talk about automated cloud bursting. That means how to actually burst from one machine to another machine. And so again, this is more situated or more focused on infrastructure as a service engineering, but it's an important part of the job, I believe. Next slide. In this module, we will basically go deeply down into platform as a services, and we will basically really focus on a tenant-aware application development. everything what is development related has some core, and I believe the core is here in platform as a service development for cloud development. So over here we will really talk about understanding differences between native platform as a services and cloud enabled platform as a services. The platform enabled platform as a service is the term coined by Gartner many years ago, and it is basically not native platform as a service. It is something which is able to run out of the cloud. Good example could be, you can take a look at the Java runtime machine. You can run Java runtime machine without any cloud, but there are platform as a services like Bluemix from IBM, which is dedicated to development of Java, as example. Obviously, you're able to develop anything else over there. But the thing is that it's not native platform as a service, and but obviously it has additional features, additional libraries. It has DevOps, which enables you to use it as a platform, as a regular platform as a service. And sometimes cloud-enabled platform as a services are even more important for corporations, because they will enable them very easy migration from on-premise to off-premise development. Same applies to Microsoft Stack with Microsoft Azure. Next section here is platform scalability and importance of open platform APIs. Next one is isolation of tenant customizations and extensions to business logic. Next section is horizontal scalability to support real-time addition of new tenants of users. Couple of sections are related here to isolation. So we do have one for isolation of tenant execution characteristics, where we are basically talking about performance and availability isolation. And then the next one is isolation of tenant workspace. This is basically dedicated to memory, how to isolate memory for particular tenants. Then tenant-aware error tracking and recovery, very important one. If something is something crashed, something is broken, it's very nice to know which tenant it is, and it's very nice to know that it's me, and I can catch this error and I can recover from that and continue as in production. Last section here is dedicated to multi-tenant data access controls. So we'll take a look at some of the data access concepts, how to do that from multi-tenant environment. I wish to spend more on this section because this is, I would say, most important section, and it's, I think, the biggest one in our course, but unfortunately we have limited time. So let's go to the next slide. Next one is dedicated to platform as a service application architecture models, and we are comparing the choices and appropriate application architecture concepts in a given scenario here. So we do have some scenario, and we will compare different concepts, how to fulfill that particular scenario. And over here we will learn about open source and technology driven platform as a services, and we will also talk about cloud enabled data access frameworks. Next slide. All right, this slide is dedicated to interoperable cloud code, and we will take a look at different interoperable platforms which are supporting this requirement. We will understand device-based platforms, and more importantly, we will learn what is the code share. That means how to share source code across organizations. A lot of people, a lot of developers are using today GitHub, Bitbucket, those kind of repositories for code sharing. But also for business purposes. And at the end of this module, we will talk about cloud persistent coding. So we will take a look what is and talk about what is the persistence and how to code persistently. Next slide. All right, these two last modules are really devoted to software as a service, and this first one is really about service catalogs and application marketplaces. So, if you go to, any application marketplace, you can download software. You can go to, Apple Market, you will download the application, etc. That's actually a service catalog. It's crossing multiple domains, but usually that's just for one device, for one category or a class of devices. Over here, we will also talk about cross-platform application cloud catalogs and markets, so which are crossing more than one device and more than one market. We will also talk about developing applications as software as a service solutions for deploying to application stores. What does it mean? Well, it means that you will learn how to deploy your application and go through the process of applying for publishing your application within the particular market. I think we do have all examples for Microsoft there, for for Apple, for Android, all these application stores. How to apply to publish my application to these particular market stores as well. Then we will learn about developing applications as software as a service solutions for single and multi-tenancy models. So what is the difference? And at the end of this this module, we will talk about bring your own device concepts. How do they apply to your development, and basically what are the benefits? And obviously, there are also some disadvantages, but mostly benefits. And we also have to learn how to incorporate this kind of thinking into the application development as well. Next module. All right, this is the last module in my section, and the name is Mashups and Open APIs. Basically, the whole module is really devoted to APIs, application interfaces. So we will talk here about API development. We will really focus on mashup orchestration and workflows. That means you can really do API development just by coding, hard coding or coding with meta sections, or you can do it in visual way. So a good example would be, you can go to MuleSoft, and this is basically integration platform as a service. And at MuleSoft, you do have this visual mapping, designer, where you can map APIs and create microservices. Basically, Mashup started as something smaller, something which will enable us just connect a couple of APIs together. But today we are talking about microservices, and very important shift from old concept with SOA to new online dynamic microservices concept running between the APIs. So that's really that part of the orchestration workflows we were talking about here. And again, it could be hard-coded, could be dynamic, and could be visualized. Then we will take a look at Mashup framework landscape. So what are the major players there? We will speak about mobile coding for a bit. For that, I will always suggest dedicated course, because that's a huge topic. But we will try to distinguish what are the differences between mobile and non-mobile coding over here. We will take a look at major social APIs, and we will basically try a couple of examples, and we will examine major open APIs such as Google, eBay, YouTube, and SoundCloud. And that's all in what is in this course, and that's all what is in my section. Thanks everybody for listening to me. If there is any question, I'm always available to answer. Hopefully Tristano will give you my email.
The third question is, to make it short, this person is a consultant and has been asked to evaluate OpenStack, and you would like to know your opinion about OpenStack, like also knowing shortly what it is and what does it mean for a company to use OpenStack instead of VMware, for example.
That's a fair question. Thank you. It's a very good question, actually. Part of my job is that I work also for IBM as executive advisor strategy for Fortune 500, and this is quite relevant question. The people are always asking me this question, but not just from obviously development perspective, but generally. So if you are asking why OpenStack, it's quite simple. It's open. All those components over there are constantly developed. It's not. It is not a shell where it's not empty. It's full of high-profile companies, such as VMware as well, such as IBM, such as Intel, etc., etc. The major probably question is why OpenStack, why not VMware? Well, it depends. Depends what if you are a VMware shop and you run everything on VMware, then probably you would use VMware also in your cloud. But if you are not, or if you are seeking forward to merge more hypervisors together, OpenStack is a very good choice for that, because basically you can really have different hypervisors and you can use OpenStack API. On top of that, you can put a couple of other tools which will create for you a single pane of glass for which you can you do your integrated and automated self-provisioning, etc. From development perspective, OpenStack is developed from the ground. It's not a proprietary software. There is a huge community of people developing on each layers of OpenStack. Good example is in IBM. We do have a OpenStack Manager piece of software which is basically running on top of OpenStack API, and which enables to provision from the OpenStack VMware images, Hyper-V images, Power-V images, images from mainframes, etc., etc. So it really depends what's your purpose, what you're trying to do. But generally, OpenStack is well maintained. It's full of people. It's very progressive, and whether somebody should, spend his or her time on OpenStack as a developer, I would say that's very beneficial, not just for the individual, but for everybody around. And moreover, again, this seems to me, OpenStack seems to me like one of the winner from open source perspective.
This person is asking if there's any difference between IaaS, PaaS, or SaaS, so from infrastructure as a service, platform, or software as a service. Which one, like, is there a difference in terms of security?
Mm-hmm. Well, yes, thank you for asking. So there are vast differences between these security approaches for each of XaaS layers. Basically, we were already talking about security on each layer, security on each component, which is a bit different than perimeter-based security or deperimeterized security. Jericho Forum from Open Group said that it's basically deperimeterized security. You are doing security on component level. You do security only on the component where you really need that security. Otherwise, it's just it's just trying to catch a fly in the air. You don't have to be successful. From a provider perspective, IaaS, PaaS, SaaS, it's a different story. IaaS, usually people are asking for compliance, based security like HIPAA, etc., or FISMA, and that means that everybody who is running, or everyone who is running IaaS-based security, that security is not just particular rack, it's the whole data center, it's connection between the data center, it's a it's a connection with internet providers, it's everything on the infrastructure layer. And so what they are saying that the infrastructure security for infrastructure as a service, the responsibility is divided. Obviously, it's divided from the ground physical level up to the software-defined data center. That means if you are talking about, I don't know, Amazon or software, then it's up to your VM. Above VM, it's your security. Up to the VM, it's a security of a particular provider. For platform as a service, it's very similar, but platform as a service could use any infrastructure as a service provider. So from your perspective, it's always a matter of perspective. So from your perspective, your platform as a service provider is taking care about the security of everything except your application. That means even for VM, etc. But particular platform as a service provider, is just encapsulating security from infrastructure as a service provider, etc., etc. As we will go higher in the XaaS stack, it's always smaller portion of security. But generally, from compliance requirements, infrastructure must be hardened for particular compliance requirements. And if there is no requirement for that, then it's just a regular model with divided security between the layers.
So this person has received a request from a client to develop an hybrid cloud solution, and is wondering if you have some recommendation for the kind of developer's profile that he needs to search for, or if it doesn't matter, is the same for a public or private cloud.
Yeah, good question. My personal opinion is it really doesn't matter. Whether it's public, private, or hybrid, that's just a deployment model, right? Obviously, if you do have some applications which are leveraging combination of deployment models, that would be probably a different answer, but generally it doesn't matter. We are not talking, or we are not really focusing when we are developing cloud applications on deployment models. We are focusing mostly, if we are talking about infrastructure service, we are focusing mostly on application scalability in horizon. That means horizontally, and obviously on availability zones. That means that if Amazon is running today I don't know, 7 to 9 standard availability zones within the US and more than 20 within the world, then basically I'm distributing my applications into those availability zones. First thing, because I have to be closer to my consumers. That means that there is no latency issue. And then secondly, obviously, if there are more availability zones within major availability zone, that means that I do have more options to, for failover and for, horizontal scalability in particular geopolitical region. It's good to me because basically I don't need backup, I don't need a DR. That's it. If one availability zone is down, another is up, and it's just serving the same customers. So really developing is, at least from my perspective, not that much, connected to what cloud you're developing for. However, if we are talking about engineering for infrastructure as a service, that's a different story, which means that we could do, again, development of orchestration of some microservices, or some orchestration or some automation of cloud bursting between the clouds. That's a completely different story. It really depends what we are trying to develop. Hopefully I answered the question.
If they recommend any publication to prepare for this certification, and first I will say something that to get this certification, you need to pass the exam, and in order to attend the exam, you need to attend the training. So you need to find an accredited training partner. But I will actually ask to Vladimir if he suggest any additional material or tool or online mock exam, courses that can help anyway to prepare for the examination? Vladimir, do you have any suggestion?
Absolutely. I mean, you know, today, again, at this era of software as a service, there are a lot of providers for trainings and certifications, but they do have different goals in their mind. So especially in your slide, you got in front of everybody right now potential certification paths. They're showing some of those providers, right, for particular vendor technology or particular section of technology. Basically, if you will go to Udemy as example, which is the biggest online provider of trainings today, UDEMY, you can download it on your mobile or run it on your browser, or even it's running even on Apple TV everywhere almost. What does it mean? There are millions of trainings and millions of people trying to learn something, and many of those trainings are cloud related, and many of those are cloud related to these technology players you've got in front of you. Good example would be IBM or Amazon Web Services. There are dedicated trainings for Amazon Web Services for each of those components, even for architecture, and even for certification path within the Amazon Web Services. So I think that's a good source where you can start. And I personally spend there probably 8 to 16 hours every week because there are a lot of new things coming every week. So I highly appreciate what those people are doing there. Many of those are not for free, but nobody's probably expecting it's supposed to be free. But the prices are very reasonable. Some of them are for $5, some of them are for $20, $30. I think the biggest one which I found was for $35. That was the highest price I ever paid anywhere for training on udemy.com. And a lot of trainers over there are professionals which are doing an excellent job. That's it.
Thank you very much, Vladimir. So I think we can close this webinar. We don't have any other question. And so please, let's keep in touch with the Cloud Credential Council. If you want to have more information, you will find these recordings and our other webinar recording and the slides on the CCC website. And if you have any queries, just write us an email and we will answer. We will try to help you in resolving your cloud problems and improve your cloud skills. So Vladimir, please accept my grateful thanks. You've been amazing. You did a wonderful job. And let's see next time.
Thanks, everybody. See you next time.